Hi dear, today we'll see the defects of the vision and its correctiveness. Okay. So what is meant by defect? Defect in vision means the eye consists of so many parts, right? Even is there any problem in even in a single part, it leads to some defects. Okay. So these may be due to the age factor or some weakness. Okay. So defect of vision. Due to the age factor or weakness of the sight, sometimes eye loses the power of accommodation. So it will lose the power of accommodation. What is power of accommodation? That is ability to converge or diverge the light rays, right? So it will loses its power of accommodation. In such condition, the person cannot see the object distinctly and comfortably. Such defects are known as defect of vision. Okay, due to age factor and weakness of the sight, the power of accommodation will be lost. Okay, so that they are not able to see the objects clearly. Such defects are called defects of the vision. Okay, but we can restore this defects. Okay, it can be treated by use of convex lens or concave lens of suitable focal length in the form of spectacles. So if you have any defects like that, so we can correct it by having a spectacles. Okay, by we know we will combine the lenses, right? So we can have it. We can have convex lens or concave lens, whatever is required. Okay, based on the defect, and also based on the defect how much power is required, on that basis we can use the spectacles. Okay, so there are mainly three common refractive defects of the vision. Okay, it is based only on the refractive defects of the visions are myopia, hypermetropia and presbyopia. Okay, these are the three common defects due to refraction. Okay, that is myopia, hypermetropia and presbyopia. Okay, other defects on the eye may be your color blindness. You very well know about this color blindness. Cannot distinguish between certain colors. Okay, and astigmatism. That is the person cannot focus both horizontal as well as vertical border simultaneously. Okay, we are going to focus only on the refractive defects here. Just want to tell you. Okay, these are the other defects. And cataract also one of the defect. That is due to the age factor, the eye lenses become milky and cloudy, right? That is also one of the defect. Okay, we'll see in detail this myopia and hypermetropia. Okay, so for directly if we compare and study means it will be easy for us to understand. Okay, so there are the first two common refractive defects are myopia and hypermetropia. Okay, myopia is also known as nearsightedness. Okay, hypermetropia is also known as farsightedness. That means they are able to see only the nearby things. Here they will able to see only the far away things. Okay, that's why they are called farsightedness. That's why they are called nearsightedness. Okay, they can see nearby objects clearly. Okay, in case of myopia. In case of hypermetropia, they can see distant object clearly. Okay, that means what? They are able to see nearby object means they cannot see distant object distinctly. Here they cannot see the near object distinctly, right? Why they are not able to see the distant object distinctly? Because the far point, their far point is nearer than infinity. Okay, because you know that the normal eye can see the object placed between the 25 centimeter and the infinity, right? Okay, but for this myopia case, the far point will not be in the infinity. It is not in the infinity. It is nearer than the infinity. So your infinity point will be shifted here. If the object is present at this distance, they are able to see clearly. Okay, if it is far away, further from this point, they are not able to get the clear image. Okay, so their far point, their near point will be 25 centimeter only, and the far point is nearer than the infinity. For example, this would be your infinity means this would be a this point is infinity means, but they are able to see the object clearly only if it is present at this distance. Okay, the far point is nearer than the infinity. Okay, from your eyes it is near. Okay, for them the near point is farther away from the normal eye point, right? So they are able to see only the distance object. They cannot see the nearby object. That means what? This 25 centimeter, this is your near point, right, for the normal person, but their near point will be further away from the eye. Okay, this is your near point of the for the hypermetropia person. Okay, they can see clearly up to a distance of only few meters. Up to this distance they can able to see clearly. Okay, likewise they can able to read or see the materials behind this 25 centimeter. When the object is present behind this, they are able to see that. When it is kept at 25 centimeter, they will not be able to read or see the things comfortably. Okay, the image of the distance object is formed in front of the retina itself. Okay, where is the image formed? It will be formed in front of the retina. Actually, if the image is formed on the retina, then only we are able to get the clear image, right? Unless otherwise we will not be able to get that. So where the image is formed in case of myopia, in the case of myopia, the image is formed in front of the retina itself. Okay, then here the image of the nearby object is formed behind the retina. Okay, they will not be able to see when the object is kept at 25 cm because it will be formed behind the retina. Okay, why it happens? Okay, this is due to the excessive curvature of the lens. Okay, if the curvature of the lens is more, it is more curved. If it is more curved, then it is excessive curvature of the lens. Because of the excessive curvature, curvature is more means focal length will be less. So the focal length is less means your converging power will be more. So it converges. Instead of slightly converging, it converges this much. Okay, it converges this much, and your focal, since your focal length is very short, so your image will be formed here. Okay, due to the excessive curvature. See the curvature. Okay, next, or it may be due to the elongation of the eyeball. Your eyeball itself, it is elongated shape. Okay, this lens have a correct converging power. Okay, correct curvature, but your eyeball itself is so elongated. Okay, so it is supposed to be like this round shape. Okay, it is supposed to be like that, but your eyeball is too elongated means the image is formed in front of the retina itself, here itself. Okay, because of these two reasons you are getting myopia. Okay, here in this case hypermetropia, it is due to the increase in the focal length. That is, if a lens is too flat, your focal length will be very long. If a focal length is very long means your converging power will be very less, right? So you will get the image here behind the retina. Okay, or the eyeball has become too small. You will have this correct converging power of the lens will be there, but what happens, because of the small size of the eyeball, your focus point falls behind the retina. Okay, so that your image also falls behind the retina. These are the two reasons you are getting the hypermetropia. Okay, then how will you correct this? We can correct this. It can be corrected by using a concave lens of suitable power. Okay, and here this farsightedness, hypermetropia, can be corrected by using a convex lens of suitable power. Okay, see how it is corrected. For this myopia person, the infinity is not their far point. So it has moved nearer to the eyes. This is their far point. Okay, if you are able to keep the object at this point, they are able to get the image properly, correct? Otherwise they will get the focus point image here in front of the retina, so they will get the blurry image. So what is our aim? Our aim is to bring the image here so that they are able to see it clearly. Okay, correction for myopia is what? We are going to use a concave lens, right? So if you place a concave lens in front of your eyes, that is as a spectacle, so the rays from the infinity, okay, it falls on its, if you use the concave mirror means what? Concave lens means it will, after reflection, it will diverge the rays, right? It will diverge the rays, okay? It will diverge the rays, but the image appears to converge. All the diverged rays appears to come from this focus point, right? It appears to form an image here. Your concave lens always form a virtual and erect image, right? It appears to converge at this point, okay? Using a suitable power of the lens, it appears to converge at the same point where their far point lies. Okay, for this person, this is the far point, means we are trying to bring the image appears to meet at the point at this place. Okay, so if the object is present here, means your eyes is able to get the clear image. Am I right? This is the reason behind it. Okay, so when it diverges, and you will get the clear image at the retina itself. Okay, next, so this concave lens brings the image back onto the retina, and thus the defect is corrected. Okay, in case of hypermetropia, we are going to use the convex lens as a corrective lens, right? By providing the it provides additional focusing power, and the defect is corrected. How? See, for them this is their near point, right? So we have to bring the image here, right? How can we bring the image here? If you place a convex lens here, the rays from this object converge further here, and it is further converged, and your image will be formed on the retina. Okay, when you place a convex lens between the focus point and the curvature, do you remember, you will get a virtual image, right? So your virtual image, it appears to meet at this point because this is their near point. Okay, this is their near point, right? If we are able to bring the object to their near point, then they are able to get the clear image on the retina. Okay, based on their near point and based on their far point, we are going to use the suitable power lens. In case of myopia, we are going to use a concave lens. In case of hypermetropia, we are going to use a convex lens. Okay, so it appears to converge at this point, and you brought back this image here for their near point image. Okay, so now they are able to get the image at the retina. Okay, this is how it is corrected. Okay, next we'll see the presbyopia. Okay, presbyopia means what? The person cannot clearly see the things which are nearby. Okay, nearby things. You know that when we are not able to see nearby things, that means they are far-sightedness, or we can call it as hypermetropia. But again, this loss, this clear picture they are not able to get, means this is due to the loss of power of accommodation of eye. Okay, that is due to the shape of the eyeball and also the increased focal length, right? But this is due to the power of accommodation. There is a loss of power of accommodation of eye. Due to the loss of power of accommodation of eye, they are not able to see the nearby things clearly. Okay, the reason is different for this case. Okay, that is called presbyopia. Okay, why there is a loss of power of accommodation, means that is due to the aging factor, the gradual weakening of the ciliary muscles. Okay, the gradual weakening of the ciliary muscle to control the lens. Okay, and the diminishing flexibility of the eye lens. They are not able to bulge or flatten. Okay, elongated or compressed. Okay, they are not able to compressed or elongated due to diminishing flexibility of the flexibility of the eye lens is lost. You know that since because of the flexibility of the eye lens only, we are able to change our focal length, right? So that we can see the nearby object as well as the far away objects. Okay. So this is called presbyopia. Here also they are not able to see the nearby things, but the reason for this is loss of power of accommodation. Okay. Sometimes some person may suffer from both myopia and hypermetropia. Okay. For that people they require bifocal lens. Bi means always two. Okay, right? Bifocal lens. Bifocal lens. Bifocal lens means it consists of both convex and concave lens. Okay, convex and concave lens. You would have seen this type of glasses. If you are any old people are there in your house, means you would have seen this one. They have some difference in their spectacles itself. There are two lenses are present. The upper lens is a concave lens for the distance vision. They will sit erect and they will view the distance object. They will slightly down their heads and then they are able to read the books using the convex lens, near vision. Okay. For the near vision, if they want to look, means they will be looking through the bottom of the lens spectacles. And if they want to see the distance object, means they can look erect and they can see through the upper part of the lens. Okay. So this is called bifocal lens. Okay. And nowadays we cannot see these two distinct lenses in a spectacle. We are using the progressive lens. Progressive lens means the shape itself will be changed. Okay, from convex lens to concave lens, concave lens to convex lens, like this. Okay, so two distinct lenses will not be used in that. Okay, some people used to wear the spectacles at the down of their eyes, so they are able to see this. They are able to see the near vision. If they want to see the distance object, they will be looking erect. Okay, look erect, look straight. Sorry, look straight. Okay, so these are the defects of the vision and the corrective measures. What we have seen: myopia, hypermetropia and presbyopia. And myopia can be corrected by using the concave lens, and the hypermetropia can be corrected by using the convex lens, and presbyopia can be corrected by bifocal lenses. Okay, thank you.